pray peace over that family. In your name we pray. Amen. And we are now recording, so part of that prayer made it onto the recording. Here's example 1. Remember, these are similar to what you have, but what they're asking for in most of this is for you to express an answer in simplest form. Okay? Express an answer in simplest form based on the variable they give you. And I'll illustrate what that means. Express in simplest form. So the first one is rather simple. A says 7 less than a number. And B says 3 times a number and 8. So what do you guys think for 7 less than a number? Jazz, what do you think? 7 less than a number. How would you word that using a variable? X n. Yep. X minus 7. And I wrote n. Okay. 7 fewer than a number. 7 smaller than a number. The number is the subject. That being said, the next one, 3 times a number and 8. Just a little tip, that and means add. Ben, what would you try for 3 times a number and 8? Yep. I don't care what variable you use, it's up to you. You're going to have several like this, and the book's example 2 gives you some more samples of how that might work. They give you a good handful more, okay? So you can take a look at those at your leisure for problems like this. Okay, here's the one where I feel like they threw us in the deep end of the pool. This isn't true, but I kind of changed the names of the cities because they have these really long city names. Well, I guess I can fix that. This is a hard one right off the bat. Okay. Her distance equals rate times time equation is slightly useful here, but we need to take this and gather our thoughts a little bit. I know that, and I'm going to sketch, from Chicago to Kansas, based on their scenario, is 600 miles apart. Okay, would you guys agree that's what I'm saying? In the story problem, it says Chicago and Kansas are 600 miles apart. So to get from Chicago to Kansas, how far must she drive? Bravo. This is what she must drive. As of right now, she has traveled this rate for that many hours, right? 40 for that many hours. Okay? So would it make sense to say that the rate or the distance she has driven, because rate times time is equals distance, is equivalent to 40 multiplied by t? Would that make sense? Since distance is equivalent to rate times time, and as of right now, this is how far she has driven, using 40t does give us what she has driven, okay? How much does she have left to drive? Using that, which was what she has to drive, and this, what she has already driven, how can we create some sort of a simple phrase to equate with left to drive? Anybody have any ideas? Jazz? She's right. So I need to drive this. I've already driven this. That gives me what's left. Great job. Great job. It wasn't abundantly obvious until you saw that if you know what you need to do and you know what you've done, you can extrapolate. In the normal world, you have 30 problems on your math assignment. You've done 15. How many do you have left? 30 minus 15, right? Just because this is a variable expression doesn't mean you can't use the same operation of subtraction. Number 3, this is the next sample. A triangle we're going to deal with. Find measure of the third angle if one angle is x degrees and the other is 15 smaller than the first. Find the measure of the third if you know something about one and the other. Okay? First angle, second angle, third angle. By the way, can anybody tell me the sum of 3 angles degrees is in a triangle? What's the degrees? 180. I'm going to write this down here because this is the key piece of information that you need to know in order to solve this. One angle is x, okay? This guy is x. The other angle is 15 smaller than the first. X minus 15. And I know the total is this, don't I? But what I want is this. What I want is that. All right. Okay, so how can we figure this out? Any ideas? There's a couple of different ways you might think about it. We're going to start off with the total. Okay, and I wish they would tell us that they're all the same, but if they didn't. So I'm going to have to kind of fluff through this a little with a drawing that may or may not be accurate. All right, this guy is x, and they don't say equilateral or anything. Okay. Well, again, we can do it this way. We know this, but we know nothing about this. All right? We cannot assume they're equilateral or anything.
Grab Prairie and proceeding to the gym, please.
But we do know, watch the video later, gentlemen, that if I take the total and remove the 2 angles, I'll have the other angle, won't I? Okay, so let's remove the first angle. That's this one. Let's remove the second one. Now this is where it gets tricky. You might just think, right, x minus 15 here. But that's not gonna work. You have to group the second angle because you are subtracting this entire piece, which is gonna force you to carry the negative here and here. The drawing just does not fit what it looks like, but okay. So far, so good. Remember, we're really not solving anything because we don't have information about anything specific, but we do have variables. So if I subtract x, so it's 180 minus x, carry that over that x, it's another negative x. Carry that negative, distribute it over the negative 15, it's a positive. Okay, again, you're thinking this is ridiculous, but really, by definition, all we're doing is defining what this is. All right? Simplify. 180 minus 2x plus 15. Okay, I could have done that. 195 minus 2x would fit. Mrs. Myers, how's that possible? Well, if I solve by using this plus this plus this equals that, I will come up with real data. And it will equal 180 degrees. It might not look like my drawing because I don't have a drawing. I don't know what is what. But I will be able to find out. I don't need to. This is all they wanted. So the total minus each EACH angle will give me the third angle. Okay? That's a tough one. That's number 3. 2 more. Okay, 2 more real quick. Whenever people talk about word problems, this is the scenario they give you, something like this. A car leaves Bradley going 40 miles per hour. 2 hours later, a second car leaves the same spot going 60 miles per hour. When will the fast car, which is the second car, catch and pass the first car? Okay, so I'm going to sketch something for you. Here's Bradley. They're going the same direction. Okay, I didn't write that, I just simplified it. And this is where they're headed. Okay, that's the direction they're headed. So car 1 leaves at a certain time, and he's trucking along at 40 miles per hour. 2 hours later, this guy starts going 60 miles per hour. When he gets to the same point where this guy is, then we've answered our question. Okay, because they're saying, when will the second guy, Mr. Speedy, catch up to our first guy, Mr. Pokey? But in order to figure that out, we need to use distance equals rate times time. Well, we don't really know anything about time, but do we? Do we know anything about one guy's time versus the other guy's time? Ben, what do we know?
The second car left 2 hours after.
Yep. So if you think about it, you can say the slow car had 2 hours more than the fast car, right? You can put it that way. And that would be time. You can also say that the speedy car left after the slow car. Either of those will work. So be advised when you look at odd answers, you might see it as a minus and it's actually a plus. Okay? But remember, we're doing rates times time, and that equals distance, right? So the rate of the slow car is 40. The rate of the fast car is 60. So using this scenario, the distance is equal to 40t plus 2. Slow scenario, or using this scenario here, his distance is t times 60, otherwise known as 60t. Okay? So when Speedy catches up with Pokey, he's going to pass him, right? What will their distances traveled be then at that point? Not exactly. Look at this line and describe how it looks compared to this line. Because this is the junction wherein Speedy catches Pokey. Do the lines look the same to you? Equal, possibly? So Slowpoke is going along and at this point, since they started from the same location, he's passing him. At this point, their distances are equal to one another. Stay with me, don't get scared. Which means at the point where Pokey is equal to Speedy is the point at which Speedy will be able to overtake and pass Pokey. Okay, using the other version, it would look like this. And it would do the exact same thing. Pokey equaling Speedy. Either of those scenarios will allow you to solve. Whether you use Speedy had 2 hours less time or Pokey had 2 hours more time. Either scenario refers to the same thing. Again, it goes back to me being older than you or you being younger than me. It says the same thing. Last one, and this one's nice and short. Give me the sum of 3 consecutive even integers if m is the middle one. Give me the sum of 3 consecutive integers if m is the middle one. Give me 3 consecutive evens just off the top of your head. 2, 4, 6, bravo. We're going to use these as my sample, and I'm going to play off of these. 4, 6. There's my sample. What's the middle one in this list? So equating 4 with m, how do I use m to create 2? If m is 4, then what must I do to m to make it 2 smaller? And what must I do to m, which is 4, to make it 2 bigger? We have now designated that, and that based on the fact that m is the one in the middle. If they didn't tell you that, you could have gone m plus 2, and m plus 4. But since they've designated this, you had to play off of that, subtracting and adding 2 where appropriate. They want the sum of these 3 things. Therefore, the sum is m minus 2 plus m plus 2. Simplifying it is going to be what? 3m, right? The 2's cancel each other. 3m. And is that correct? 3m, m is 4. 4 times 3 is 12, right? Is 4 plus 6 plus 2 12? Yeah. So I came up with a sample creating a visual representation of 3 consecutive even integers. I responded to what they wanted me to identify as the middle one, came up with what I believe represented that, and then went back to my sample thought process with which I was able to prove I was true.